The second part of this lecture was now what about the sump tank? What I mean by the sump tank is this one. This is the intake. This is what the screen, and this is the pipes, and the pipes are, we have n a number of pipes, and the diameter of each of one is 5. So we should, based on the velocities on these pipes, we have a V actual velocity, we have V minimum, we have V maximum. So peak. The V actual will be equal to the Q divided by N divided by area of each pipe, which Q maximum monthly. Now, the V minimum is equal to Q minimum divided by N, also an area of each pipe. And the V maximum, or the peak, is equal to Q maximum monthly divided by N minus 1. This is in case of emergency, and area of each pipe. And this should be less than 1.5, this should be greater than 0.6, this should be less than 2.5, and so on. Now we agreed to have how many pipes, and we have agreed to the diameter of the pipes. Now it's the time to check this tank. This tank dimensions, usually it will be here. This is the side view. If I have looked, let's have a look on this way. There is a pipe here, there is a pipe here, and there is a pipe here. So they come inside this one. Then I should put, this is the length. This is the, and usually it's a concrete, this is the length, this is the width or B. And there will be a depth. So the question is, how much is the L, B, and D? Length of the pipe. So based on the pumps that we have here, for example, we have a pump here, we have a pump here. What we should do, we should use if I have using two pumps, so this pump here, and here's one other pump. So for each of them, they need us to put at least from 1 to 3 meters. So it means that, sorry, this is the length. To 1 to 3 meters. There is a 1 to 3 meters. So means the length will be affected by the number of the pumps. As much as you have more pumps, then the L will be increased. This is what the dimensions say. But before that, we need to know how much is the volume of this tank. The volume, here's the volume. The volume of this sump tanks or suction well will be here. We have the design flow, which is the Q maximum monthly. We have the minimum flow, which is the minimum times the Q average. So remember that this maximum monthly, it will consider as a D, and multiplying this Q average by 0.7 will consider as a minimum. So minimum, it means that design maximum divided by 2. The volume of this tank will be either of those two ones. Either we will multiply the Q times 2 minutes. So if I have the Q is 1,000 meter cube per minute, so usually we need not let the water stay in this tank for more than 2 minutes. So what that means, 2 times 2,000, 1,000 means you have to have a tank of 2,000 meter cube, the volume. Or if you have, well, this is the peak, so the peak divided by 2, we can get minimum 1 sorry, this one times 0.7 means that the 1000 times 0.7, it means 700 times 5 minutes. This is meter cube per minute. So 5 times 500 is 0.0300. So we have two volumes, either 3,500 meter cube or 2,000 meter cube. Which one I should use? You say that use the maximum of them. So the volume of the SAM tank will be the maximum of either the maximum monthly or minimum times 5 minutes. Now, after we know the V, so the volume is equal to L times D times B. Length, depth, width. Length, length, width, depth. This words are usually it will be between 1 to 3, so we don't have anything with this one, but the L will be affected by the number of the pumps that we have. So we should have a space between each pump to another one. So in case that we have 3 pumps, so we should have a space between each pumps from 1 to 3. This means 1 to 3 meters. Now, in that case, if I have 3 pumps, let me say I have 3 pumps, and the space between each pump is 1.2 meters. So I should allocate 1.2 meter for each pump. So now the L is equal to 3 times 1.2 meter means 3.6 meter. At least the length of the tank should be there. Now, number of pumps, I mean by the whole number of the pumps. Usually when we need 2 pumps, I will say I will put 3, 1 just in standby, because we have to have a standby. Now, the total number of the pumps, it means the working and the standby pumps. B, the B is the for 1 to 3, this is assumed and this is standard. Now, what will be the diameter? Now, we have the volume, we have the L, we have the B. So what's left? The left is T. We can find this one easily by dividing the volume by L and B. And usually it should be more than D minimum. What is that D minimum is? D minimum is when you have water. Yeah, when we have water in this is the river, and this is the bed level of the water of the river. Now we have put this pipe here. The water is coming in this pipe and towards the sun. It will be collected here. So the water, when it's coming from this pipe from here to there, it will lose somehow energy. What is that energy is? It's HF, and you know from the fluid mechanics that HF is L over D V square over 2G, and it will depend on the length of the pipe and the diameter of the pipe and the friction factor of the pipes to get that HF. So it means the low water level, look the low water level, minus HF, will be the first step. Then D minimum should be, here is the bottom level. This is 0.5, so this is how much? This is the bottom level minus 0.5. So you can tell me now what is the D minimum. D minimum is equal to low water level minus HF minus B bottom level minus 0.5, which means what? Which means low water level minus HF minus times 1 plus minus and minus times minus positive. So here's the D minimum. D minimum should be more. Yeah, this D, when we have the volume divided by L divided by B, it will give you a D, which is the depth of the tank. It should be greater than the D minimum. Otherwise, you have to put the D minimum as an indicator. Is it clear? Yes.
Are those equations given in the exams and quizzes?
Yeah. But you have to know how to apply them.
Yes.
Yeah. As a homework now, I want you, for this example, we solved this example, right? Now I want you to find the volume of the sump for this example. Use 3 pumps. Now we found that the number of the pipes that will be, here's 3y. Okay. So I will, now in this pipe, we have 3 pipes, but with the sump tank, we need to have 3 pumps. So do this homework and please submit it by night to me, how to find, I want you to find the volume of this sump. How to find the volume? You have the Q, yes, we have the Q, this is the design Q. And this Q design times 2 minutes, or Q minimum times 5 minutes, you will find how much is the volume that's really required for this one. And when you have V, you have to check for the B. B will be between 1 to 3 meters. Now the L, it's important. The L is the length of the number of the pumps in this sumps times 1 to 3 meter. So that's the L, that's the B. You will find the, or the left thing is the D. Find the D, and this will be the homework. Okay, guys. Any problem, any question, anything you have in your mind? Ahmed?
Thank you, Doctor.
Thank you all. So don't miss to submit your answer by noon. Okay?
Doctor, I have one question.
Yes.
What kind of examples are you focusing on for the exams and quizzes?
All the ones that you have in the lecture notes.
Okay.
Yeah.
Gotcha. Thank you very much.
Yeah, thank you. And please
Have a nice day.
submit, yeah, for you too. Please submit your answer of this homework by tonight.
So, Doctor,
Yes.
we have to submit it in the classroom, right?
Yeah, I will assign now I will,
Okay.
I will assign an assignment for you. And please, like always, submit your PDF file there. I will
Okay, Doctor.
name it as homework number 1. Okay.
I think we did homework number 1.
So sorry, this will be in homework number 2. Okay.
Okay.
No. Okay. Thank you all.
Thank you.